Yes, ma'am.
Yes, yes. So, first topic is mean value theorems. Already you know. Um, so, first one is Rolle's theorem. So, actual statement is Rolle's theorem. Let f of x be a function such that it is continuous in closed interval ab and it is differentiable in open interval ab. And third condition is if f of a equal to f of b such that there exists a c which belongs to open interval ab, so then f dash of c equal to 0. So this is the main three conditions of Rolle's theorem. So if a function is said to be satisfy Rolle's theorem, then the three conditions will be satisfied. What is that? Continuous, differentiable, and third one is if f of a equal to f of b, there exists a c such that f dash of c equal to 0. So what is the main point here is, so we take xy plane. So here there is a unique tangent line at every point c. By Rolle's theorem, there is at least one point x equal to c between AB on the curve at which the tangent is parallel to x-axis. Okay, this is a very important point. Okay, the curve at which the tangent line is parallel to x-axis. Okay, and now first we go for first question. Verify Rolle's theorem. One main point is another point. Another main point is there exists a C which belongs to in the interval AB, given interval AB. Okay, na? It should lies in between AB. So this is important. So verify Rolle's theorem if the function f of x equal to sine x by e power x or e power minus x sine x in the interval 0 comma pi. Some standard results are there. What are they means? Sin x trigonometric functions and exponential functions are both continuous functions in closed interval AB. Okay, one of the properties, some standard properties of continuous and differentiability. So sin x, since sin x here our f of x is combined with sin x and e power x, that is sin x by e power x. So since sin x and e power x are both continuous functions in closed interval 0 to pi, therefore sin x by e power x is also continuous in 0 comma pi. Again, we go for second point. So our second point is differentiability. So we can call differentiable or derivable. Since sin x and e power x be derivable in open interval 0 to pi, then f is also derivable in open interval 0 to pi. Okay, so now we check the conditions. What is the third one? Third condition that our a is 0, our interval is 0 to pi. Okay, so interval is 0 to pi, a is 0, b is pi. So we check the condition, that is f of 0 is sine 0 by e power 0 and f of pi is sine pi by e power pi. So we know the value of sine 0 and sine pi is also 0. So function is, that is f of 0 is 0 and f of pi is also 0. Hence it is equal. So third condition is satisfied. Also, first condition is satisfied, second condition is satisfied, third condition is satisfied. So there's all the three conditions of Rolle's theorem are satisfied. There exists a C such that which belongs to 0 comma pi such that f dash of c equal to 0. So what is f of x? Sin x by e power x. And what is f dash of x? U by v. What is the formula of u by v? v into u dash minus u into v dash by v square. That is, so v means e power u is sin x, v is e power x, v into e power x into differentiation of sin is cos minus sin x into differentiation of e power x is x, x itself. Okay, here there is a small mistake here. So taking e power x common, sin x into e power x. So e power x common, cos x minus sin x by, so by cancelling e power x, we get cos x by minus sin x by e power x. So we want f dash of c equal to 0. So that is f dash of c equal to 0 means cos c minus sin c by e power c equal to 0. So from this we get cos c equal to sin c, implies either cot c equal to 1 or tan c equal to 1. Now c equal to tan inverse of 1 means we know the angle pi by 4. I mean tan inverse 1 value pi by 4. So this pi by 4 value, that is c value, which lies in between 0 to pi. Isn't right? So pi by 4 is lies in between 0 to pi. Okay, so this point is also satisfied. So hence Rolle's theorem is verified. So we observe all these three conditions should satisfy. Hence Rolle's theorem is verified. Then only we said that the given function for Rolle's theorem is satisfied. Okay. So if any one of these conditions doesn't satisfy or does not exist, so we say that Rolle's theorem is not verified. Okay. If any one of these points, either one first point or second point or third point or last C. So if C is does not belongs to in this interval, suppose, so we say that Rolle's theorem is not verified. So next, go for second problem. Understood all of you first one? Move on immediately. Yes. Okay.
Yes, ma'am.
Next, go for second one. Okay. Using Rolle's theorem, show that the given function is here represented by g of x has a 0 between 0 and 1. Okay. So that is, so here g of x, it is a polynomial function. In the first question, it is both the trigonometric and combined with, in the above question, the function is combined with trigonometric and exponential. So, but in this question, the given function is a polynomial function. So, this is also a standard property, that is, every polynomial function is a continuous and there exists a differentiable. So, for these given polynomial function, both first two points are satisfied. What is that? What are that? It is continuous on closed interval 0 and 1 and differentiable on open interval 0 and 1. Now, g of 0 is 1. Substitute 0 in the given polynomial, we get the value 1. And substitute one value in the given polynomial, we get also 1. Hence, g of 0 equal to g of 1. Okay. Also, so from this, we can say that g of 0 equal to g of 1. So all these three conditions are satisfied. So there exists a C, one point which belongs to 0 comma 1 such that g dash of C equal to 0. So what is g dash of x? First of all, differentiation of x cube is 3x square, that is 8 into 3x square is 24x square minus 12xc. I mean, in terms of, I'd say in terms of g dash of c, minus 12c. Okay, so that is g dash of c equal to 0 means 24c square minus 12c minus 2 equal to 0. So now we can find roots by using the formula c plus a minus root of b square minus 4ac by 2a. So finally we get two values for c, that is 0.63 or 0.132. So we take only one value which lies in between 0 and 1. Okay. So one of these values, one of the values is 0.63 gravity. So we take C is 0.63 which lies in 0.1. So satisfied, which exists. So there exists at least one root between 0 and 1. Okay. So hence Rolle's theorem is verified. Okay. So likewise, we are doing like this Rolle's theorem problems. So see the third one. So see the fourth one. Since what is our f of x? So it is also being a polynomial which is continuous and differentiable on the interval is minus 3 comma 0. So their product is, first of all, what is a given f of x? X into x plus 3 into e power minus x by 2. Okay. Now what is the first two points are satisfied, that is continuous and differentiable. So differentiable, there is a derivative exists. So f dash of x is x into x plus 3 into uv. This is derivable in the form differentiation of uv. What is the formula of uv? U into v dash plus v into u dash. Okay. So likewise, we extend the formula and finally we get e power minus x by 2 into 6 plus x minus x square by 2. Since f dash of x does not become infinite or indeterminate at any point of the interval minus 3 comma 0, so f of x is derivable in minus 3 comma. So it is a differentiable value exists. So given function is derivable in open interval minus 3 comma 0. Also we have f of minus 3. By substituting minus 3 value in f, what we get? Substitute x equal to minus 3 in the given function. What we get? Respond. S
0, ma'am.
0. Very good. Similarly, substitute x equal to 0, we get also f of 0 is 0. So hence f of minus 3 equal to f of 0. Hence all the conditions are satisfied for Rolle's theorem. There exists at least one value of c such that f dash of c equal to 0. So we find the f dash of x here. Now we replace c in the place of x. So that is f dash of c equal to 0. Finally we get c square plus c minus 6 equal to 0. And the factors for these are c minus 3 into c plus 2 equal to 0 and c equal to 3 comma 2. Sorry, 3 comma minus 2. So clearly c equal to any one of the values of c. Okay. So c equal to minus 2 which lies in the given interval. So for this we say that hence Rolle's theorem is verified for the given function 9 minus 3 comma 0. So this is about Rolle's theorem. Next we go for Lagrange's mean value theorem. Let f of x be a function such that, so listen carefully, observe that the conditions of Rolle's and Lagrange's mean value theorems are almost the same, but one condition is different. That is f dash of c equal to f of b minus f of a by b minus a in Lagrange's mean value theorem, whereas in Rolle's theorem f dash of c equal to 0. So this is the main difference. And geometrically, we explained that there is at least, see the diagram here, we take xy plane. So there is at least one point C on the curve AB such that tangent line is parallel to AB, parallel to the chord AB. So this is the important point. So in Rolle's theorem, it is parallel to x-axis. Okay. Now, so let us see the statement. Let f of x be a function such that it is continuous in closed interval ab. Second point is differentiable in open interval ab. There exists at least one point c in open interval ab such that f dash of c equal to f of b minus f of a by b minus a. So the main difference point is for Rolle's and Lagrange's is f dash of c. In Rolle's theorem, f dash of c equal to 0. In Lagrange's mean value theorem, f dash of c equal to f of b minus f of a by b minus a. Next. So we go for problems. First question. Verify Lagrange's mean value theorems. Mean value theorem for the given function. So our given function is which type of function? What is a function form? Which form?
Polynomial one.
Is very good. So it is a polynomial form in the interval 0 to 4. So we have to check that the C which lies in 0 to 4 or not. Okay. So here our question is just to verify Lagrange's theorem. If all the three properties are satisfied, then Lagrange's mean value theorem is verified. So if one of the properties is doesn't satisfy, then we say that Lagrange's mean value theorem is not satisfied for the given function. So let us assume f of x, not assume, let f of x is a polynomial in x, and we know that every polynomial function is a continuous and derivable. So that is f of x is a continuous in closed interval 0 to 4 and derivable in open interval 0 to 4. Hence, by Lagrange's mean value theorem. So here we need not to check that f of a equal to f of b. So it is not there here. Okay. So hence, by Lagrange's mean value theorem, there exists C which belongs to. Okay, here it is ma SS. So C belongs to open interval 0 to 4. So now f dash of C equal to f of b minus f of a by b minus a. So f dash of C is, what is f dash of x? 3x square minus 2x minus 5. So which is equal to, substitute 4, f of 4 and f of 0 values. So what is f of 4 value? Substituting 4 in the given function, we get the answer 31, and substitute 0 in the given function, we get 0, we get 3. So from equation 1, we substitute 3c square minus 2c minus 5 equal to f of 4 value is 31 minus 3 is 28. Okay, 28 by 4 is 7. Again, by simplification, 3c square minus 2c minus 12 equal to 0. So finally, we get the roots by using the formula minus b plus r minus root of b square minus 4ac by 2a. C is 1 plus r minus root 37 by 3. So we take here only positive value. Okay. So we see that 1 plus root 37 by 3 which lies in the interval 0 to 4. So thus all the conditions are satisfied, hence Lagrange's mean value theorem is verified. Okay. Likewise we do for Lagrange's and Cauchy's mean value. So this is also important theorem. So if so here also it is f comma g. Here it is two functions. Whereas in Rolle's and Lagrange's we have one function. So here it is f and g. So that is first point is fg or continuous. And second point is fg or differentiable. And third point is g dash of x is not equal to 0. Then there exists a point c which belongs to a comma b such that f dash of c by g dash of c equal to f of b minus f of a by g of b minus g of a. So this is the main condition. So remaining 2 points are also similar to that of Rolle's and Lagrange's. And third point is g dash of x not equal to 0. And the main formula is this. So see this question. First question. Of Cauchy's mean value theorem for f of x equal to root x and g of x equal to 1 by root x. Okay, so clearly fg are continuous and differentiable. So what is f dash of x? What is the differentiation of? Listen carefully. First of all, you should have the main basic formulas of trigonometric, all differentiation, integration formulas. Then only you can do. Okay, you will do. So now f dash of x is 1 by 2 root x and g dash of x is minus 1 by 2x root x. So f comma g are continuous and also differentiable, and g dash of x is not equals to 0. So three conditions are satisfied, and condition are next f dash of c by g dash of c equal to f of b minus f of a by g of b minus g of a. So that is now substitute f dash of x in the substitute c of x in f dash of x. So we get 1 by 2 root c, and g dash of c is minus 1 by 2c into root c is equal to f of b is, what is f of b? Root b minus f of a is root a by g of b is 1 by root b minus 1 by root a. So by taking LCM on both sides, so we get root AB equal to C. Okay, by cancelling some terms on both sides, by simplification, finally we say. So C equal to root AB. So our main interval is A comma B. Okay, that is, so C equal to root AB. So we take for any values of AB, C equal to root AB is which lies in between AB and, isn't right?
Yes, ma'am.
Okay, so which verifies Cauchy's mean value theorem. Okay, similarly, like this is the f is e power x, g is e power minus x in the interval 3 comma 7. So exponential function is a continuous and derivable, and the condition, three conditions, e g dash of x is a, what is g dash of x? Here we get minus, so minus e power minus x, which is not equals to 0. So there's a three conditions are satisfied such that f dash of c by g dash of c equal to f of b minus f of a by g of b minus g of a. So which implies we get, so differentiation of f is e power x, so differentiation of g is minus e power minus x. So by substituting in this formula, we get the 2c. Here it is minus e power, so 2c equal to 10, comparing powers of exponential term. C equal to 5, so which lies in 3 to 7. Okay, hence Cauchy's mean value theorem is verified. So these are all about Rolle's Lagrange's mean value theorem. So we have to so again I'll repeat. So these first two conditions are almost same for three theorems, Rolle's, Lagrange's, Cauchy's. So for Rolle's theorem, third point is f of a equal to 0, f of a equal to f of b. There exists a c such that f dash of c equal to 0. Whereas in Lagrange's mean value theorem, same, first two points are same, such that there exists f dash of c equal to f of b minus f of a by b minus a. For Cauchy's mean value theorem, same, first two points are same. And here there are two functions f and g. Okay, and third point is g dash of x should not be equal to 0. There exists a point c such that this is the formula. So these are all about Cauchy's mean value theorem. Okay, understood all of you? Yes.
Yes, ma'am.
Okay, next shall I go for next topic? second.
Madam, is there any questions previously asked, ma'am, in GATE through these three theorems?
Simple questions, ma. Not more difficult problems. So they'll ask a similar simple questions. So e-screen is visible?
Yes, ma'am.
Yes. So our next topic is so you have to remember there's three theorems formulas. Main f dash of c equal to 0 for roles, and f dash of sorry f dash of c equal to f of b minus f of a by b minus a for Lagrange's, and f dash of c by g dash of c equal to f of b minus f of a by g of b minus g of a. So you have to remember that these 3 points main, okay, so that you can do any problem, whatever they given, okay. So our next topic is here theorems of integral calculus. So already you know in these are in intermediate, okay. So well, we will see the integral of a product of a constant function. It is equal to product of a constant. And the integral of function is so if there is a constant in any integral function, we take outside. We will write outside of the integral. We don't write inside. So one of the properties. Next, the integral of sum of difference of a finite function is equal to sum of differences of integrals symbolically represented by. So we split the integral functions. Okay, that is integral f1 of x plus a minus f2 of x so on dx equal to integral f of x dx plus a minus integral f2 of x plus a minus so on integral fn of x dx. So these are the main fundamental formulae you can see here. So we know the previously I told you. So you have to remember the basic formula. That is a fundamental formula. So integral x power n dx is x power n plus 1 by n plus 1. These are the main formulae. So you know this and the useful trigonometrical identities. So you will form these trigonometric values. Next, transformations formulas. Sine of minus x is minus sine x, cos of minus x is cos x. Transformation, sine of x plus y is sine x cos y plus cos x sine y. Likewise, this is a fundamental formula. Okay, so which are useful in the integrals. Okay, next, tan x plus y equal to tan x plus tan y by 1 minus tan x into tan y. And tan of x minus y equal to tan x minus tan y by 1 plus tan x tan y. And direct result tan pi by 4 plus x is by using this formula. This is the formula 1 plus tan x by 1 minus tan x. So, so these are the fundamental formula. You know this. So here there are some questions. Assuming I equal to root minus 1 and t is a real number. So integral 0 to pi by 3 e power it dt is. So you can calculate easily. So here there is a solution. Exponential function integral is e power it. So we have to do integration with respect to t, that is e power it by I between the limits 0 to pi by 3. So by De Moivre's theorem, we know the formula e power I theta. What is the formula?
Cos
Yes,
theta
respond
plus I sin theta,
immediately.
ma'am.
Very good. So cos t plus I sin t by I between the limit 0 to pi by 3. Now substitute the upper limit minus lower limit, we get the value. So here there are some options. So, you know, okay, root 3 by 2 plus I into 1 by 2. So this is the solution. So this question was asked in the year 2006, 2 marks for mechanical. Okay, next. So integral, uh, the integral 0 to pi sine cube theta. So here, so directly we don't know the value. So we convert, uh, we have the formula sine 3 theta in terms of cube, or by substitution method. Let it be sine cube. First of all, our question is integral sine cube theta. So we convert sine square into sine theta d theta. So we write sine square theta is 1 minus cos square theta into sine theta. So next, so here we take substitution. Let cos theta is t minus sine theta d theta is dt. So we have to change from theta to t, total integral. And the limits may be changed or not, may not be. Okay. So once we will check. If theta equal to 0, what is t? Cos 0 is 1. If theta equal to pi, what is t? Cos pi is minus 1. So that now the limits are changed from 0 to pi is from minus 1 to 1, and d theta is, I mean minus sine theta d theta is, sorry, sine theta d theta is minus dt. So here it is minus. So by substituting 1 minus t square into dt, next term by term integrate. Integral 1 dt is t, integral t square is t cube by 3 between the limits minus 1 to 1. By substituting the upper limit minus lower limit, you know the format, upper limit minus lower limit. All of you know.
Yes, ma'am.
Okay. So need not to explain this. You can do. So finally the value is 4 by 3. So here the answer is C. So this question was asked in 2006 for easy. Okay. Um, so likewise these are the integral problems. And next, see here, integral 0 to pi by 4, 1 minus tan x by 1 plus tan x into dx. So in the above previous, I mean fundamental formulae, uh, tan pi by 4 minus x is, directly we write 1 minus, this is the formula. Okay, so we can write, there are two methods. So we follow either first method or method 2 as your wish. Okay, so directly we write, log root 2 is equal to 1 by 2. Root 2 value is 1 by 2. Okay, likewise we write. And another method is we convert into 1 minus tan of pi by 4 minus x by 1 plus tan of pi by 4x pi minus x. So again we have the formula tan a minus tan b, that is tan a minus tan b by 1 plus tan a tan b. So likewise we integrate and we get the same answer. Okay, this is the fundamental formula. Next, methods of integration. No, one second. Integration by substitution. Uh, so we have the rule, uh, three forms of integrals. So we know the formula integral f dash of x by f of x dx is integral. Um, Direct formula is log f of x. You need not to prove this proof. Okay, so we need not. So directly this is the formula. And important problem is, so integral 4x cube by 1 plus x power 4 dx. Okay, so how we will solve this problem by taking compulsorily substitution method. Okay, 1 plus x power 4 is t. Here they didn't give limits. Okay, so how can we will solve this problem means, put 1 plus x power 4 is t by differentiating on both sides 4x cube dx. So here this formula applies, that is integral f dash of x by fx. What is f dash? 4x cube. F is 1 plus x power 4. So that is log 1 plus x power 4. Okay, directly. And we know the another formula, f of x whole power n into f dash of x dx equal to f of x whole power n plus 1 by n plus 1. This is also one of the formulae. Next, integral of a product of two functions. Um, differentiation of u dv by dx plus v into du by dx. Okay, and one of the important concept is here Eilert method. So all of you know Eilert process is Eilert method.
Yes, ma'am. The term which is to be integrated first, ma'am.
Yes, suppose listen once again I'll explain you. So where we can use Eilert method means in the integral function if there are two functions that is uv. So first we write Eilert. I means inverse trigonometric functions, L is logarithmic function, A is algebraic function, T is trigonometric, E is exponential. You know this. So first we take in these, in these order. So where the first function is there, I suppose integral x into e power x. Suppose for example, x is an algebraic function and e power x is a exponential function. Which function is first? Suppose, hello, hello, yes,
X is
hello.
first, ma'am. Last is
Ah,
exponential, ma'am.
okay. So integral x e power x means, so suppose the question will be integral e power x into x. So where we can take first function. What is u? What is v?
Ma'am, U is X, ma'am. V is e power X.
Very good. So by using this Eilert order, okay, and formula for this is integral e power ax and bx dx. This is a direct formula, okay. So you should remember. Next, partial fractions. So direct formula for, so 1 by x square minus a square dx is 1 by 2a log of x minus a by x plus a. Next, uh, can any one of you can take snap for this class? Yes, Supriya. Yes, Supriya. Can you able to hear my voice? Sir, ఇప్పుడే లాస్ట్ 10 minutes ఇప్పుడు కట్ అయిపోయింది సార్. అదే సార్, అందుకని లెఫ్ట్ అయిపోయారు నేను చెప్పకముందే. పర్లేదా సార్? ఇప్పుడు ఇంటగ్రల్ టాపిక్ కంప్లీట్ అయిపోయినట్టేనా? 3. అవును సార్. దాన్ని బట్టి చెప్తున్నాను. ఇప్పుడు లాస్ట్ మూమెంట్‌లో ఒక 10 మినిట్స్ ముందు కట్ అయిపోయింది. అది మళ్ళీ ప్రెజెంట్ చేయాలా నేను అని. లాస్ట్ మూమెంట్‌లో సార్. ఒక 2 ప్రాబ్లమ్స్ ఉండుంటాయి. అంతే కదా, సరేలేండి. నేను ఇంకా చూడలేదు సార్, నేను మీటింగ్లోనే ఉన్నా. ఆ, ఆ, ఉమ్, అవునులేండి. ఓకే, బెస్టే కదా. అవునవును. ఆ, ఓకే ఓకే, ఇంకా రికార్డ్ అవుతాను సార్, నేను ఇంకా స్టాప్ చేయలే, స్టాప్ చేసేసానా? సరే సార్, ఓకే సార్. సరే సార్, ఓకే ఓకే.